before we proceed for model building activities or analysis, right? Before analysis, we need to prepare our data for analysis, right? So to prepare data for analysis, we need to do all these things. So it's important that you understand how to play with data, how to summarize data, how to merge different tables, okay, how to aggregate different functions, how to generate pivot tables, right? How to create derived variables, and that's how this session will be important for all of us. So I've already imported pandas library, and now let's create a data frame. Like say d equal to. Uh, these are all key value pairs, as you know, right? So this is one key value pair name. This is one key value pair exam. This is one key value pair subject. This, okay, and subject this one, and then last key value pair is score. Okay, this is the score. So from this data frame, if we create a pandas data frame, we'll get four columns: name, exam, subject, score. So df equal to pd dot data frame of this data frame d, columns equal to, we are giving say names here. Even if you don't put column names, it will be taken care because I have key value pair in dictionary, right? So keys will be taken as columns. But in case you want to change the names, you can do by columns equal to name, exam, subject, or score. And then let's say print the data frame. So it will generate name, exam, subject, and score, right? Now, once we have this data, suppose we want to do something like, say, we want to check the count of some of the columns, right? So how to check the count? Like, say, suppose I want to check the count, total number of observations for say column name. Okay. So df name dot count will give me the total number of observations for name column. Okay, which is 12. As you know, like Python starts from index 0, so 0, 1, 2, 3 till 11 will be the row numbers, but we have 12 elements, 12 observations for name. Similarly, if you put exam here, it will give 12 count, subject also 12 count, score also 12 count. This means total number of observations, right? That's how you can get the total number of observations from a particular column from a pandas data frame, right? Now let's say if we want to check like what was the highest score among all these, okay, among all the semester, among all the subject scores, what is the highest score? So that you can get it by like df of score and then dot max function. Okay, these things you can directly apply like df score dot max. So this will give you the highest score. So let's see. So if you can check like what is the highest score out of all these scores, it will be 89. So 89 you are getting it, right? Now suppose I want to understand the total score of Elisa. Elisa has repeated entries: Elisa 85, Elisa 67, Elisa 74, Elisa 62. So 62, 74, 67, and 85. I want to check the total score of Elisa in all the subjects in all the semesters. How to do that? Say df um, score. First of all, you will you will take the numeric column for which you want the summation, right? And then you will put the condition like df name equal to Elisa, okay, and then dot sum, okay. So first you will give the numeric column or whatever you want, average or summation, etc. Then you will give the condition df name equal to Elisa. So I want to find the scores only for Elisa, and then I will sum it. Okay, okay. So basically, again, as per my definition, like go from right to left. So summation of scores, right, for name equal to Alisa. So let's see, it will be total 288. Okay, because 62 plus 74 plus 85 plus 67 becomes 288. So by that script, you got the summation of total score. I mean total score of Arisa, right? Now, if I want to check like how many entries for say each name, okay, like names are there, right? I mean here names are repeated like Elisa, Lisa, then Catherine, Catherine, Bobby, Bobby, those things, right? So I want to check the how many counts for Elisa, how many counts for Catherine, how many counts for Bobby. So how to do that? Like say if I put like say name df name dot value counts, okay, this will give me the number of observations for each name or each category. If I would have been using a categorical column, right? So df name dot value counts will give you the count for each name, each individual name. So Alisa had 4 entries, Bobby has 4 entries, and Catherine has also 4 entries. Okay. And name, like because you are calling the name column, so name is name of the column, and data type equal to int64, right? Got it? Clear, all of you? You can write yes in chat box if it is clear.
Yes.
Okay, good. Now, suppose you want to check the non-null unique name entries. Okay. Uh, sorry. So df name dot n n unique will give me 3 because 1 minute. Okay. So df name dot n unique will give me 3 because there are 3 unique names. Okay. So n unique means number of unique values. N unique means number of unique values for this name column. So obviously I had 3 names, Elisa, Bobby, and Catherine, and not more than that. So it is 3, right? And say number of non-null exam countries. What I mean, exam column. What are the unique number? So 2. Exam is like semester 1 and semester 2. That's why 2. What is the unique entries for subject column? Subject was only mathematics and science, so that is also 2. So its count is 2, right? Now let's say we want to get all the unique names. I mean the values we want to print it. Okay. So that time my code will be df.name.unique. Okay, df.name.unique. Here I'm putting df.name because there is no space in the column name, right? But what did I mention earlier? That if there is space inside column name, that time you can't put like df dot something or a space of space dot thing. That won't work. That time you give like this one, right? I'll show you. That time you need to give it inside a third bracket and then inside single quotation. I'll show you. So df.name.unique will give me all the unique values. Okay, like Elisa, Bobby, and Catherine. Right, these values. So you know now like how to check the missing entries, duplicate records. Okay, unique entries, unique values. Okay, how to calculate the total score of a single column, etc. Now, as I mentioned, like if there is space, so here there is no space, but if there is a space, you can write the column name like this: df third bracket inside quotation name or whatever column name is there, like say name of person, etc. So name of person is, with space that would work. Okay, dot unique. This will be again same as this one, obviously, because we want to check the unique values of name column like Alexa, Bobby, Catherine. So hope it's clear. So this is a bit of the summarization of data. There are more summarization. So I'll show you when I cover statistics class, like what are the statistical summaries along with these normal summaries, and it will be more interesting, right? So there are a lot of summary that we can achieve. So now let's say merging. Okay, merging is important because suppose our data could be placed here and there. We can have so many tables, we can have so many databases, and that's why it is important that uh, we do merging, we do concatenating, etc., right, to prepare the final analysis data set, and then proceed for analysis or getting the summary. So let's proceed. So suppose I want to create a data frame of random numbers, all the random numbers from 0 to 1, and I want to get say 10 rows and 4 columns. So df equal to pd dot data frame np dot random dot rand n random numbers, and then converting the data frame to 10 rows and 4 columns. So let's see all random numbers, 10 rows and 4 columns, right? Here remember that I have not given any index, specific index names or column names. So Python index names have been generated, Python column names have been generated by default, right? So which is starting from 0, 1, 2, 3, and 0 till 9, because 10 rows. Now suppose I want to break this data into multiple pieces. Okay, so break this entire data into multiple pieces. How can we do that? Suppose I am going to create this object pieces equal to say df is to 3. You know, like is to 3 means 0 to third index row. That means from 0 till second row, right? I mean third row. Third row is like 0 2 index, right? And then I'll take the second data frame, like which moves from 3 to 7th, and then third data frame should be from 7th till last. Okay, so third data frame will be like this one, and this one, and second data frame will be 3 to 7. So uh, so 3 to 7 is like this one, this one, this one, this one, this four records, middle four records, 3, 4, 5, 6. And what will be my first data set? Df is to 3, that means 0, 1, 2. This one, this first three rows will be data frame 1. So here I'm going to create a list, like this is the list, enter list, and inside the list I have three data frames. So as you know, like list can contain any objects. In Python it can contain arrays, it can contain numeric values, it can contain categorical values, it can contain both numeric categorical, it can contain dictionary, it can contain data frame also, right? So list can contain any object in Python. So now let's print pieces. So I'll get like this. So this is the first data set. This is the second data set. This is the third data set. As I mentioned to you, like for pieces, uh, one will be like pieces zero will be like, so this is zero zero zeroth index for pieces. This is one index for pieces. This is two index for pieces, right? So pieces zero will be this data frame. Pieces one will be this data frame, and pieces two will be this data frame. Got it? So if I print pieces zero, can any one of you say like what will be printed? Which data frame?
It's 0 to
The first
2.
one, 0.
Yes, you are right, because I have divided the data into pieces, and this is zero piece, this is one piece index. I mean this is second index, two index, right? First data frame, second data frame, third data frame, but index is 0, 1, 2. So if I want to access the divided data frames like pieces zero, then it will give me this data 0, 1, 2. Okay. What will be giving me pieces one? It will be giving like 3 to 6,
3,
the
4,
middle
5.
one. 3, 4, 5, 6. You are right. 3, 4, 5, 6. And then what is the rest? Like 7, 8, 9, right? So pieces two will give me 7, 8, 9. So like we learned like how to divide data into multiple pieces, and we also learned how to access the pieces, right, through index. So sometimes it could be important, like you need to divide the data into multiple pieces. How? Like say you want to divide the data by gender. For male you want to have a separate data set, for female you want to have separate data set, and then you want to access the male data set, you want to access the female data set, like this, right? And not only gender, but suppose you want to get it for country, you can do the same. For say ethnicity, you want to do that. For ethnicity also you can do it, like say for Asian, for African, for Indo, those things, right? There are so many ethnicities across the globe, and you can access data for cities and so on, right? I hope you got it. Now let's say you all might be knowing about column bind and row bind, right? So let's see. So basically, suppose I want to, I have this different like pieces, different data frames. Suppose I want to row bind. Row bind means all the rows. So these are rows, right? 0, 1, 2 is row, 3, 4, 5, 6. These are different rows. 7, 8, 9. These are different rows. Suppose I want to merge this entire data frame again. No more pieces. I want to get in a single data frame, and I want to merge in urban. Urban means row bind. So what it will do is it will bind all the rows together, and it will be back to original data set. Okay, how to do that? So by you can do that using concat function. Okay, so pd.concat. Concat means concatenation. pd.concat of pieces. If you run this, it will again concat all the rows together. It will move back to the original data sets. Let's see. So now no more three pieces, all has been added. 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, and then 7, 8, 9, all put together, right? That's how we can concatenate different pieces of data or different data sets. Okay, now let's say we create a data frame like this is one key value pair, name, score 1, score 2, and score 3, right? So print my df, okay, and this is one data. And suppose we are going to create another data, new df equal to pd.dataframe, which is having only single column, score 4, okay. So first data frame is having 4 columns, name, score 1, score 2, score 3, and second data frame is having only score 4 column. So now let's see. So this is like my df, and this is new df. Okay, my df has 4 columns, new df has 1 column. Now, if I want to column bind means binding the columns. Okay, earlier we have seen like binding the rows. Now, say we want to bind the columns. So what we want to do is we want to merge or concatenate my df and new df. So how to do that? CDF. Suppose my new df is CDF equal to concatenate CDF Sorry, I think I have network issues. Am I back? Can you hear my voice?
Yes.
Yeah, I can hear.
Okay, okay. So sorry for that. There's glitches on internet. Like access equal to one, because access equal to one I am need to put because I want to merge all the row values for these columns. Okay, all the row values, index values for this column. That's why access equal to one. So cdf equal to pd dot concat my df comma new df comma access equal to one. This will do a column bind. Now see, this cdf data frame has concatenated both my df and new df. And my df, remember, we had 4 columns. New df had 1 column, so 1 column has been merged, concatenated with cdf and this new cdf, right? So interesting, right? Now let's say we have say left data set and right data set. So left data set is having say key value, key column as state, and low L value means lower side value, so 1, 2. And say right side data is having key state, and right side value is having 4, 5. So let me print it like what is left and right data set. Left right data set is like state key, and left side value 1, 2. Right data set is having key state, right side value is 4, 5. Now if I want to merge, so pd dot merge left comma right. uh, so this is a merge command. Okay, earlier we have shown concatenated column script. Now this is merge. How it will happen? Basically, it's like SQL style merge. Okay, you know SQL style merge. So what happens is for the state one, right? State, there are two repeated columns. So how it will move is like 1, 4, 1, 5, and then again for this two, this state 2, 4, 2, 5, right? So that's the merge column, like state 1, 4, 1, 5, state 2, 4, 2, 5, right? You can ask me like how to merge everything together. I'll show you one by one. Okay, so that's how it is getting merged. And if you put like, so this is like SQL style merge, but you can specifically do SQL style merge like pd dot merge left comma right on equal to key. So like by which key? Like on equal to key. This is key only single column because this key column is present in both left side dataset as well as right side datasets. If I have two different key column names, how can I merge? I'll show you. Okay, so let's see it. It will give the same output as earlier because by default these are same key. That's why by default it's putting like this merge. And if you specify like on equal to key, that will also do this much same merge because as I mentioned for state this is repeated, so 1415 for state again repeated, so 2425, right? That's how it merges. Okay, now you got it. Now let's say we want to create this data frame like L key, lower side key equal to state, dist, city, state, and value equal to 1235. Right side key is state, dist, city, state. Okay, value equal to 5678. Okay, now let's print it. So this is left side data, L key and value, R key and value. Now check, now no more key and key column. So there is no unique column for both the data sets. My keys are different, L key and R key. So I raised a question, right? If I have different key columns, how to merge it? It's easy. So df1 dot merge, df1 dot merge of df2 comma left key equal to, let's define left on, left underscore on equal to L key. So what is the left key? Left key is L key, and what is the right key? Right key is, so now I need to specifically define like what is the key for left data set, what is the key for right data set, because the keys are different. Okay, that's why. So if I merge it, so what's happening is say state, okay, for state one, for the state key it's repeating, say state and state. So how it will be generating 1518. For dist also, dist is also like repeating, right? So for no, dist is not repeating, dist and is not repeating, so like it will be 26 and 58. Okay, so 1518, 555. Okay, so 5 I missed, right? So 5 is state, so state is also repeating. See, state key is also repeating like 55 and then 58, 55 and 58. And for dist is not repeating, so 2 6, and city is also not repeating, so 3 7. So what will be the merge, inter merge? 1518 5558 2637. Got it, right? Clear, all of you? You can write in chat box if it's clear. Hello, can you hear me? Okay, good. Now suppose this value, remember here the value of x and value of y, this came as additional columns. This value means value from x, I mean the left side, x by default, this is x, this is y. Python considers it. Suppose I want to change the name of these columns, value underscore x and value underscore y. How to do that? So L, so suffixes. Okay, so this is the syntax, like suffixes underscore left underscore right. This will change me the xy, which is considered by default using Python. So now L key same code, only I'm putting suffix 6 for this value column as left and right. So the column names will be value underscore left and value underscore right. That's all. Outputs will be same because this is same key, same command actually. df1 dot merge df2 left on equal to L key, right on equal to R key. Right. Got it. So let's execute. So this will be value left, value right because of this one, because we have put suffixes. Okay, now let's say we have another two data sets like A column, data from one is A column state dist and B12, and df2 state city, and C column is 3 4. So let's print it. So we have df1 state A state dist and B12, A state city and C 3 4. Now there are if you all know about joining, like there is left join, there is right join, there is inner join, right? uh, how those things works. Left join works like ensures that whatever keys you have on the left hand side, those are retained. Okay, it does not consider the right side keys, but mandatorily you will retain the left side keys. And what is right join? Right join, you will mandatorily keep the right side keys, but you don't care about left side. You take the value, but these keys must be present. Okay, that is right side joining, right join. And what is inner join? Inner join is it will compare the common keys. Okay, so for these two data sets, the common key is state, right? So inner join will be giving me state key only. So that's the difference between left join, right join, and inner join. So let's do that one by one. So now have a look at the data again. So this is df1, this is df2. So how can we do left join? Df1 dot merge of this data frame, df1 dot merge df2. Like I want to merge df1 and df2. How equal to left? So this is left join on which key? On equal to a. So this is a key column, a and a. Column key columns is same. The names of the key columns are same in both the data sets. That's why I just need to put on equal to a, right? If I put this and if I execute this, check the data. Like data one has state and dict. I mentioned that for left join, it makes it ensures that these keys are present, ignoring these keys. Okay, so state dict column, I mean keys or indexes are in left side, right? So left side is mandatory taken. Now for state, B column is 1 and C column is 3, right? So 1 3. Okay, and for dist, B column is 2 and C column no, dist does not have dist index is not there in df2, so it will be null value for C column, right? So bc state 1 3, it came from both the data frame, and dist it came from both the data frame, but since dist index is not there in data frame 2, so it took null value. Got it? That's how left join works. Clear, all of you? You can write yes in chat box if it's clear. Okay. What is right join? Right join is this ensures that these keys are present, state and city. Let's see. df1 dot merge df2 how equal to right on equal to a, same script except how equal to left, and where we are putting how equal to right. So I mentioned state and city must be there. So state and city must be there, which is there. Yes. Now for state it is 1 B column. You know B column is coming from data frame 1 and C column is coming from data frame 2. So 1 3 it will be same like the state column. What will be city? City for B column it will be null because city index is not there in data frame 1. In data frame 1 the indexes that I have is only state and dist, no city, right? So city will be null value for B column. So city will be null value for B column. And 4 value because it is present in df2, so 4 value is coming from df2, right? That's how it is doing right join. So good. Now let's say put inner join. So you all know like inner join is only having state, and since already we have values for B as well as C column, so it will be like state B column value 1, C column value will be 3. So let's do it. So inner join df1 dot merge df2 how equal to inner on equal to a. This will give me only state key or state index, and value from data frame 1 is 1 B column, value from data frame 2 is C column, which is having 3 value. Okay, good. Now so Python by default considers if your keys are same, like df1 dot merge, if you do like this, it is by default an inner join. df1 dot merge df2 just without putting these things, it is by default inner join. So same output as this one. Okay, what is outer join? What is outer join? Anyone? What is outer join? Who knows? Can you explain what is outer join quickly?
Yes, sir. It will give a result in which there are records from left and right data frames and the common
Right.
ones.
So right, from both the sides, whatever keys are there, it should be present. Okay, it ensures that the keys or indexes are considered from both the data set and then merged as per the values and keys. Right. So let's say outer join. So df1 dot merge df2 how equal to outer. See, I'm using the same script. Only thing is how equal to inner, how equal to left, how equal to right, and how equal to outer. On equal to same because key columns is same for both the data sets. Now, the state, dist, and city. If you remember, in data frame one, I had state and dist column, and in data frame two, I had state and city column. Okay. So now, if I merge outer join, I mean outer join is state, dist, and city. It ensures that all keys or all indexes are present. So state yes, dist yes, city yes. For state, we had both the values, so 1 3. For disk, remember it had from df1, but this index was not present in df2. That's why this two value is coming from df1, but null value is coming from df2 because disk index is not there in df2. And city column, if you remember, it was city index, it was there in data frame 2 but not in data frame 1. So from data frame 1 it is null value, from data frame 2 it is bold value. Okay, so you have understood concatenate function, you have understood merge function. Now there is one more function, join. Okay, so either one you can use, and depending on your situation, depending on your need, you can use merge, you can use concatenate, you can use join. So let's see how join works. So suppose I have this data frame df1 equal to key. These are the key. Okay, I'm not repeating. This is key value pair. This is a value, right? Okay, and df1. Suppose this is the df1. Okay, which has key 0, 1, 2, 3, 4, 5, 6. And suppose I have df2 key 0, 1, key 0, key 1, key 2, and its values b value. Okay. Okay. Now how join function works? df1 dot join df2 l suffix, because I want to we are doing by key, right? So basically key underscore x or key underscore y will be generated in Python by default. I want to change the name, so l suffix equal to underscore scholar, right? This one, and right suffix equal to underscore other, so key underscore other. Okay, if you join it, okay, then what it gives is it will take key from column, I mean left side, key from right side. So by default Python will be key underscore x, key underscore y, and we have renamed it already underscore scholar and underscore other, and a underscore value which is coming from say the right left side matrix, and right side, I mean a value which is coming from left side matrix, and b value which is coming from right side matrix. So what will happen? Key 0, you remember that key 0 and key 1 and key 2 were present in both the data sets, right? So what it will do is it will join a value and b value from both the data sets for this key. So a value 100, 116, b value, I mean a value and b value for second row 102, 117. This is coming from data frame 1. This is coming from data frame 2. This is coming from data frame 1. This is coming from data frame 2. This is coming from data frame 1. This is coming from data frame 2. But key 3 is not present in data frame 2, so null value. This is again coming from data frame 1, which is having 1, 1, 12 value in data frame 1, and null value from data frame 2 because key 4 column, I mean, sorry, not column, index or row is not present in df2. Similarly for key 5, key 6. That's how it joins, right? Got it? Okay, suppose I don't want to get two columns for the key columns, right? Now how to do that? That we can do using this syntax like df1 dot set underscore index key. This is the column. This is the syntax df1 dot set underscore index key, and dot join df2 dot set underscore index key. If I specify this, it won't be creating two columns for key. It will going to create only one column. So key 0, 1, 2, 3, 4, 6. Other values will be same. A value and B value, 100, 116, 102, 117, 110, 121, 111 null, and null because 3, 4, 5, 6 had present in data frame 1, and 3, 4, 5, 6 did not have presence in data frame 2, right? Okay, that's all about merging, concatenating, joining, right? Clear? All of you? Is it clear? You can write yes or no in chat box. Okay, good. Now let's say group by. Group by again is like it works like summary only, but here we are going to group by some of the columns. Okay, earlier we have seen like how to get summary, count, summation for a particular column. But if you want to group by, like group by for some other column, like say some of the categories like by city, by name, or say by ethnicity, etc., and you want to get some like mean score, average score, sum of scores, etc., that time you can do it by group by and by pivot tables. I'll show you one by one. Let's see first group by. Okay, suppose I have a data set like my df, which has again key value pairs. I'm not repeating name, score 1, score 2, score 3, score 4. So print my df is like It will generate names, all the names, score 1, score 2, score 3, score 4, right? Suppose this is my data. Now I want to check says mean score 1 of the student, mean of the score 1 of the students. So how to do that? My df of the numeric column, as I mentioned earlier, if you remember, my df of numeric column dot group by dot condition. Earlier we have put condition, now we are using group by. Okay, so group by the aggregating column. Okay, aggregating column is, suppose I want to aggregate by name. Okay, so group by my df name dot which function I want to suppose get the average score one for each name. Okay, average score of each name. So how it works? Suppose Elisa, right? Elisa had three entries, one, two, three. Any more? No. So like I want average of score one for Elisa. That means 67 plus 32 plus 71 by 3. It's like all of us know how to calculate average because we have studied mathematics during our junior classes, right? Average is nothing but summation of the values by total number of observations. In statistics, this is also called mean. Okay, MEAN, mean. So 67 plus 32 plus 71 by 3, if you put it, that value, I mean, you'll get like for Elisa and for say Alex will be this one. It has for Alex it is only one entry. Okay, so it will be 53 only, 53, right? For Teresa we had two entries, so 54 plus 60 by 2. For Andrew it has two entries, so 57 by plus 52 by 2. Okay, so what it is doing is it is grouping by all the names, and for each name it is giving me mean. That's the objective. For mean for which column? Score one column. So for each name, because I have done group by the names, right? So it is giving me average of score one for Alex, average of score one for Alisa, average of score one for Andrew, average of score one for Teresa, right? So this is important in statistics. Like you want to get the average of the scores or say average population for each city in India, right? That time the scripts will be useful. Okay, so you got it clear, all of you? Okay. Okay, now let's say now say I want to group by name. Okay, so this same script can be written in different way. Like my df. Okay, initially my df. I'm not putting the numeric column in advance. What I'm doing is my df dot group by. First time I'm putting the condition or group by. My df dot group by name. Okay, dot ag. So this function works like this one only, but it's a bit syntactically different. My df dot group by name dot aggregate. I mean aggregate of which column? Like score one column. Okay. So this aggregate function need to be defined in a dictionary. So the key will be the column name and value will be the aggregated function. So there are a lot of aggregated functions. Here I'm going to put summation. Okay. So aggregation of score one column and I want to take summation. So what it is going to give me is for each name, it is going to give me the summation of all the score one. Okay, for each name, it's going to give me the summation of score one. So for Alex, it is 53. Remember, it has only one entry. So summation of one entry will be that entry only, 53. And for Elisa, remember we had three entries, right? Three or four entries, I guess. Three entries. So 67 plus 32 plus 71, which is 729, and then 8 11 and then 17 170, right? 170, Alisa 170. Similarly for Andrew 109, because for Andrew 57 plus 52, so 109. For Teresa 54 plus 60, so 114. So 114. Got it? Got it? Right? Now, suppose we want to get this mean score 2. It is same actually, just you want to put the numeric column different. My df score 2 dot group by my df name dot mean. It's going to give me mean score 2 for each student. Mean score 2 for each student. Okay, Alex has mean score 2 as 72. mean score 2. Elisa has mean score 2 of 94. Andrew has mean score 2 of 69. Teresa has mean score of score 2 of 53. Okay. Now suppose I don't want to specify the score columns. I want to generate all the scores, all the scores. I mean, whatever numeric columns are there, I am to get mean values of all of it. So what do I need to do? I do not need to specify in a single column. Instead of this, I just directly put my df and dot group by my df, my df name, group by which column, and then I'm putting mean. Okay. Remember, I'm not putting any specific column which I need to aggregate either summation or mean. Here, I am based on this syntax, it will aggregate all the numeric columns. And earlier I had numeric columns like score 1, score 2, score 3, score 4. Let's see how it happens. So for each name, it is going to give me average of score 1, average of score 2, average of score 3, average of score 4, because I have not used specific column, right? That's how it works. Okay, got it? Now, let's say we are going to create another data set like where name is having this one, exam is this one, subject is mathematics and science, and score equal to this one, right? So if I merge this data, I mean change the column names, bd dot data frame d, columns equal to name, exam, subject, score, print df. So this is the data frame like name, exam, subject, and score. Okay, got it. Now suppose I want to get the summation of scores, these scores, group by name and exam. So now earlier I used group by only for a specific column, single column. Now say I want to group by first name and then by exam. Okay, how to do that? So DF score I mentioned earlier repeatedly, like first say DF of which column you want to aggregate numeric column. So DF of score, then group by. Remember here I mentioned if you have two column names, then you must put inside a list. So DF name, comma DF exam, I'm putting inside a list because these are two columns. So group by first name and then exam dot sum. So I'm using summation for this score. So group by name and exam. So total scores. So total score for name and exam. Right. So like for each name, for each exam, what is the total score? So for Alisa, total score for semester 1 is 136. For Alisa, total score for semester 2 is 152. Okay. Here Alisa is there, semester 1 is also there, semester 1 is also there, semester 2 is also there. So what it does is for Alisa semester 1, 62 plus 74 is the value. Okay. And for Alisa semester 2, 85 plus 67 is the value. And that's how it is coming here. Alisa semester 1 total score is 136. Alisa semester 2 total score is 152. Similarly for Bobby, I'm not repeating. Similarly for Catherine. Okay. So group by name and exam, then summation of scores. Now say I want to put say by three columns. Okay, name, exam, and subject. Same script like df of score, the numeric column, then the condition or group by three columns. I need to put inside a list df name, df exam, df subject. Okay, then aggregated function. Okay, this will give me sum of the total score by name, by exam, by subject. So this means Alisa semester 1 in mathematics, how much score he got, total how much total score he got, 62. In science, how much total score he got, 74, and so on for Bobby and Catherine. Similarly, okay, okay. Suppose I have to group the entire data frame by subject and exam. Okay, by subject and exam like df dot group by subject and exam. No more aggregating function by any specific column. Okay, that will give me the aggregating function for the numeric columns by default in Python. Okay, so df dot group by subject comma exam is going to give me group by subject and exam, and then the total sum means total scores. So subject and exam, subject is coming and then exam is coming. First grouping by subject and then grouping by exam and then summation of all the scores. This means mathematics semester 1 total score was 164, mathematics semester 2 total score was 192, science total score in semester 1 was 182, and so on. Science semester 2 total score was 237, right? So that's how you can aggregate all the different options, and you can get average values, you can get total values, you can aggregate by different column, single column, more than one column, two columns, three columns, and so on. Okay. Now suppose I don't want to
I have
use.
a question.
Yes, please go ahead. Yes, go ahead.
Hi, Nishant.
Hello,
So
your voice is cracking,
the question that
not
I've
clear.
been
Voice is not clear. Maybe you can write in chat box. Your voice is not clear. Can anyone of you hear his voice? No, right?
Can you hear me
No,
now?
no,
It's breaking
no.
actually. I can hear you in pieces, but
It's breaking. Yeah.
not properly. So maybe you can write in chat box. I'll answer. Hello. Okay. So okay, while he's
Hi,
region,
hi, Abhinash.
yes,
I have one more question for you.
yes, go
Yeah,
ahead.
in the last example, I think we just group by based on subject and exam. We didn't specify the score,
Right,
right? So
right,
it's automatically taking
right,
the score and summing it off. In the previous
right,
examples and all, we are specifying which
right,
numeric values to be
right.
sum up.
Absolutely right. You are right. You are right. So let me give an example. Suppose in your data set, remember the data set that we created had only one numeric column score, right? But it may happen that in your data set you have multiple numeric columns, and
Okay.
it may happen that you may want to query, like say for a specific score column, or say for a specific, say like what is his psychological score, or say IQ, etc. Okay.
Mhm.
Suppose I have IQ score, I have psychological score, and I have exam score. These three columns. And suppose you want to have you want to study only the IQ score. That time you can put IQ score here, and not the exam score or not the psychological score, right?
Okay. Yeah.
That's the need for a specific column. And
Mm.
suppose you don't want to specify any column, that time if you use this script, you know what will happen. It will give you the summation or average, whatever function you use it. It will give score for, some score for score column also, like exam score also, IQ score also, and psychological score also. Whatever numeric columns will be there, Python will give you the summation or mean for all the numeric columns. Here I have only one numeric column, that's why it is only one numeric column. Got it?
Yeah. Okay. Got it. Yeah.
Okay, right.
Thank you.
No problem. So okay, so now let's move to pivot table. Pivot works is similar to group by, but it is like Excel pivot table. If you all know Excel pivot table, it works in the similar fashion. Like say I have df equal to abc three columns, and abcd five columns. These are like a1 a1 a2 a2 1 1 1, and small large d and d columns have values. So let's print quickly. Like a has some keys like a1 a2, b has some keys like 1 and 2, and c has some categories like small and large. Okay, and I have values in d and e. So you'll understand. I think Abhilasha asked me question, right? Now you'll understand, like so there are two numeric columns d and d. Okay, so how can we do it? Okay, so what's the syntax? Pd dot pivot underscore table. Pd dot pivot underscore table. This will generate pivot table. Okay, pivot table of data frame and value is equal to d. So this value is equal to d means aggregating column. Okay, value is equal to d. That means this numeric column. I am specifically mentioning that I want functions, aggregating functions for this column and not for e column. Okay, and what will be the index? Index I want to put a comma b. That means only for a and b column, not for c column. For c column, I am mentioning that it will be in a column. Okay, so column equal to c. So I'll show you how it looks like. So column equal to c. These values are coming from column, and these indexes is coming from a column and b column. And then I'm going to put aggregate function func equal to np dot mean. Okay, so what I want to do is I want to find average of d column, only d column, because value is equal to d, right? Average of d column for a and b, and column is for small and large. Okay, so So for small column, for large column, what is my average D for A and B? Okay, now let's see how it works. So I have put index equal to AB. So index equal to AB, right? This is rows A1, 1, 2, and A2, 1, 2, right? This is like working like group by, okay? And columns I have mentioned C. So this is columns, large and small, two categories for columns. So large value is one column, small value is one column, and then aggregating function of mean of D. So check now. Um, okay, C is a column. So first let's see for small. A1 1, I have one value, and then A1 1, A1 1 small, A1 1 small, A1 1 small. Okay, I have only one actually. So D value is one. So one average of one is one only, right? So I'll get like A1 1 small 1. So A1 1 small 1. Okay. And similarly, I'll get A1 1 large, A1 1, A1 2 large, A1 2 small, A2 1 large, A2 1 small, A2 2 large, A2 2 small. Did you get it? Clear? So in row, I am using AB, and in column, I am using C, which has two categories, large and small. So by default, it is going to create two different columns. For large, it is one column. For small, it is one column. And finally, I am going to calculate average of D column, which are these values. Okay. Okay. Now, similarly, suppose I want to use columns A and C in place of column A and B. I'm going to use index A and C. Okay, and column equal to B. Column equal to B. So how will it work? And now my aggregating column is E, no more D. So what I want to do is I want to get average of E column, not D column anymore. Average of E column for AC and for columns B. So B has categories like 1 and 2, remember? So for 1, it's a separate column created. For 2, it's a separate column created. And these are indexes because I have defined AC as index. So A1 large 1, this is some average of E score, E column. A1 large average of this one because this is not present actually. That's why this is not A1 large 2 is not present in dataset. That's why null value. A1 small 2 is 5.5 average of E column, and that's how it gets it, right? Now, suppose I want to get, I want to show three aggregating functions, minimum, maximum, and mean score for both the columns, like for the both the columns D and D, not single column, for both the columns D and index equal to AC. So rows will be AC, and so this syntax is a bit different, like PD dot pivot table of data frame value is equal to DE, which aggregating columns you want to use it, index equal to AC, and then ag function, because you want to use multiple aggregating functions, then we need to use ag function equal to inside this dictionary mention all the column names and their respective function. Okay, D np dot mean, E mean max, and mean. So for D column, I want to get only the average. For D column, I want to get only the average. And for E column, I want to get max, mean, and mean. Okay. So let's see what it does. It is going to create index AC. A column is A1, A2, C large, small, and then it is going to create, say, uh, two columns because DE, I want to have aggregating functions for DE. So DE, and for D, I mentioned that, okay, I want average. So for D, only average. And for E, I mentioned that I want minimum, maximum, and average. So for E, minimum, maximum, average. So what will happen is for each AC, okay, the mean value of D will be calculated here. The max, mean, and mean value of E will be calculated here and accordingly put in a table. Right? This is a pivot table. Got it? All clear? I mean, are you clear? Have you understood properly? Any question? Okay, excellent. Now, similar to pivot table, say we need just pivot. Okay, in pivot, the difference is we don't put aggregating functions. We are just using some pivot like tabulation, you can say, in statistical tabulation, proper tabulation. So let's see, df equal to pd dot data frame. M, this is one column, N, this is another column, O is another column, P is another column. So let's print it. m column, n column, o column, p column as per this definition. Okay. Now if I put df dot pivot, no more pivot underscore table, only pivot. So df dot pivot index equal to m. So index equal to m means the rows values will be m coming from m column. Columns will be from n columns. So n column has a b c three categories, right? So there will be three columns created a b c and values equal to o. So values from o column. So 1 2 3, right? So what it is going to do is going to create a pivot table by index 1 to index m columns. So it has only 1 2 and say by columns equal to n. So columns equal to n, right? A B C. That's why I told that A B C column will be created, and then values will be O. So how do I want to represent? I mean, in the middle values will be coming from O column. So it will be repeated observations. It won't sum or it won't average, but it will consider all the observations. So check from this table, like for one, for M, uh, for one ABC values are 1 to 3. So ABC 1 to 3. For two values, ABC are 4, 5, 6. So for two value, ABC are 4, 5, 6. So that's how it has created a pivot for us. Got it? This is very easy to understand, like how the data is structured, and quickly you can from here. It's not so easy, right? If you have a large data set, but from here, from the tabulation, proper tabulation, it's very easy. Okay, for M1 category, for NA, I have one value, and this value is one. For M1, for B NB, I have two. I mean, value is two. Okay, that's clear, all of you. Okay, great. Now we are done. We are done mostly with pandas. Pandas will be covered today. From tomorrow will be. So basically, Python program is almost covered. Tomorrow we can cover like file reading. Okay, file reading from Python. Before moving forward with visualization and data preprocessing. Okay. Now, say I wanted to cover some of the derived variables. In statistics or data science, derived variable is an important aspect. Suppose, let me give you an example. Suppose you are a telecom, you have a telecom company. I mean, you are the owner of a telecom company, and you have a lot of customers. And suppose the customers have some like start date. Okay, when did they subscribe firstly? Suppose I subscribe in 2011. Someone from you among you, like subscribe in 2010 or 2016, 15, etc. We all have different subscription dates. Now I want to create a derived variable. Suppose like say my entire tenure. So what will be the tenure? Like current date, today's date minus that subscription date, and that is going to be derived variable because that variable was not present in the original data set, but I am deriving that variable. So to create a tenure variable, right? That's the function. That's one important aspect of derived variable. Now let's see how to create it. Suppose df underscore rect says rectangular. We are going to create it pd dot data frame height, okay, and width. So I have different height values, different width values. If I print it, I will have height column and width column. Suppose I want to calculate the area. So df rect area, this is going to be a new column equal to, okay, df underscore rect is data frame dot apply. You all know about lambda function. So dot apply directly lambda of x. Okay, this is an unknown object lambda of x such that x dot height into x dot width. Okay, what I am going to do is I am going to create a function lambda of x where it will just take height variable or height object of x object, height column or height variable of x object into width column or width variable of x object, and it will multiply. And by each row values I want to make it. So x is equal to 1 by each row, right? Say 10 into 5, 20 into 2, etc. by each row. So that's why x is equal to 1. Now this will create me a new column area which will multiply height and width for this object, because when I put apply function, this x will be replaced by df underscore rect. Okay, so let's see how it creates. Okay, got it. So now height width, and I mentioned like 10 into 5, 50, 20 into 10, 200, 30 into 50, and 450, 40 into 20, 800, right? So this function created a new column area. This is a derived column. Earlier, my data had only two columns. Now I have derived the columns, or I have created a new column area, and this is the formula. Now let's say I have another data set like date, event, and cost. Okay, suppose I want to, I'm giving say 10% discount. Okay, so what will be the final cost? If I put 10% discount, so what will be the final cost? I am going to create a discounted price column. Okay, so df discounted price equal to df cost, this cost. Okay, df cost, this cost, minus 0.1, 0.1 because 10%, 10 by 100 equal to 0.1. So minus 0.1 into cost again, right? So df cost minus 0.1 into that df cost, that reduces the 10% cost from the original cost, and then it is going to give me the final price, which is the discounted price. So let's create it. So from 10,000 minus 0.1 into 10,000 is 1,000. So 10,000 minus 1,000 is 9,000. 5,000 minus 0.1 into 5,000 is 500 less. So 500 less from 5,000 is 4,500. 15,000 minus 0.1 into 15,000, which is 1,500 less. So 1,500 less from 15,000 is 1,355,500. And from 2,000 minus 0.1 less, so that means 200 less. So 200 less from 2000 is 1800, right? So same thing, if we wanted to use using apply function, how could we do it? Yes, we can do it. Df discounted price equal to df dot apply. Remember, df dot apply lambda of val such that val dot. So here you can put x also. Okay, anything you can put. So lambda of val such that val dot cost minus 0.1 star val dot cost. Okay, comma x is equal to 1. So this will give me the same output as above. Only I have using apply function. So date, event, cost, and discounted price. Okay, all clear. That's done actually for today. And pandas is done. Pandas is covered.